Good day, and welcome to another edition of Toolbox Tuesday. Before I start the presentation, I just want to take a few moments to discuss a few items. This Toolbox talk is recorded, and as with many of our other informative Toolbox talks and webinars, it can be found on our YouTube and Facebook media channels. If you're joining through those channels, remember to give us a like and share, and be sure to subscribe to keep up to the date with the safety in Saskatchewan. Our topic for today is in regards to some of the perhaps lesser known legislation, not only to help familiarize you in this particular legislation, but to also serve a reminder to refer to your acts and regulations prior to or while assigning a task. The acts and regulations here in Saskatchewan are not something that is necessarily new to anyone working in the industry. Most people involved in the B rate codes understand the Saskatchewan Acts and Regs governs activity on the job site. Most of those regulations are very easy to understand. However, some of them have caused some confusion in the past. For today's Toolbox talk, I would like to take some time to talk about a few regulations that, in my experience, companies have had trouble understanding or were in violation of them without even knowing. Most workers involved in construction understand there are many dangers within the construction industry and have gone to great lengths to mitigate those hazards. But there are some dangers that workers may be less familiar with, and as such, may not recognize them as critical danger that can cause crippling injuries or death. One example of this is high pressure injection injuries. With heavy equipment, there are many hazards to recognize and control. Most workers are familiar with the need for competent drivers, high-vis vests, and proper maintenance. An area that may be a lot less familiar, however, can also be the most potent threat: high-pressure hydraulic leaks. A tiny break or pinhole in a hydraulic line or a failure of a fitting can release hydraulic fluid in an almost invisible stream at over 200 bar, which is 3,000 psi. If technicians or operators are searching for a leak with their hands or investigating some unrelated problem, they might feel a sting similar to an insect bite or a sharp wire cut and not consider it serious at first. The wound may not even appear to be that severe, just a cut or a red mark like an insect bite. Mechanics, carpenters, plumbers, electricians, well, just about everybody in the trades can get bumps and scrapes on their hands all the time. However, within a few hours of this injury, it can cause excruciating pain and require immediate and specialized surgery. The longer emergency treatment is delayed, the higher the risk of permanent injuries such as losing fingers, the whole hand, or even death. That brings us to the legislation. Pressurized hoses. 920. An employer, contractor, or owner shall ensure that an effective restraining device is used on a hose, pipe, or connection that is under pressure if inadvertent disconnection of the hose, pipe, or connection could result in danger to workers. There are plenty of options when it comes to protecting workers against injuries caused by failure to pressurize hose, pipe, or connections. First, whip checks have been used for years on hose and pipe with less than 200 psi. It is very important to understand the limitations of these types of products. Whip stops are another that have been used and are akin to finger straps and can handle much greater psi. It is also important to note that when we think of injuries caused by the failure of pipe or hose, we often think hydraulics. It should be noted that injection injuries can happen with any substance under pressure as little as 7 bar, which is 100 psi. Even water or air. Many common maintenance shops activities such as pressure washing, painting, cleaning debris with compressorized air, and use of a high pressure grease gun can result in injection injuries. Example 2, pallets and storage racks. Housekeeping is one of the best ways to reduce the risk of same level falls. And there is no better way to organize an area than to put materials and tools up on storage racks. Have a series of storage racks in your shops is very common in almost every workplace. What is uncommon is the knowledge of legislation surrounding storage racks. 919. An employer, contractor, owner, or supplier shall ensure that pallets are maintained in a manner that will permit safe lifting of the pallets. Racks for the storage of material or equipment are designed, constructed, and maintained to support any load placed on the racks and erected on a firm foundation. This legislation is saying a few different things. Let's break some of this down. First, pallets are maintained in a manner that will permit safe lifting of the pallets and the pallet loads by a forklift truck or other device. What this is saying is that your pallets cannot be broken or mishandled to the point that they can no longer support the load imposed on them safely. The pallet must be in sound condition in its entirety. Oftentimes, material shifts during the shipping process and can break the pallet, not to mention the loading and unloading phase. If at any point the pallet's condition changes to the point that it no longer can be lifted safely, the product must be moved to another pallet, or the process to move the material must change to not include the pallet. Secondly, we have 919, which states racks for the storage of material or equipment are designed, constructed, and maintained to support any load placed on the racks, and they're erected on a firm foundation. This is the one that generally goes unnoticed. If you're a business owner and you bought or leased your property, there's a good chance that in the back of the shop, all the racking was left. You most likely have no idea when it was constructed, who constructed it, and most importantly, what the weight restrictions are. Knowing how the capacity of your storage racks is important to keep workers safe and preventing a dangerous collapse. Here's where the problem is. Regardless of when a storage rack installation was designed, commissioned, and installed, the original stamped and sealed engineering documentation detailing the maximum safe capacity should be kept on site within a facility. However, chances are that paperwork is likely kept in a filing cabinet and not easily accessible to the users charged with operating and maintaining the system, or it's just non-existent. Without easy access to the original design information, operators frequently make changes to the system configuration or utilize pallets that exceed the system capacity. Unknowingly, this creates a potential unsafe operation and work environment. This is why the legislation is written the way it is. When you read designed, constructed, and maintained to support any load placed on the racks, you may look at your storage rack and think it's fine to support the weight that is on it, or that will be on it. However, without the information detailing its weight restrictions with the current design, you cannot prove that it can handle the weight. If LRWS happens to pay your shop a visit, make sure you have that information available. If you cannot provide that documentation, you'll have to hire an engineer to certify the weight limit in its current state. Lastly, the storage rack must be on firm level ground. This is very important as the racking is only as strong as the ground it is built on. For example, a single rack that measures 8 foot long and 36 inches deep with 3-inch by 1 5/8 column can support 16,700 pounds. If we change to a different size rack, like 20 foot by 42 inch deep with 3-inch by 3-inch columns, it can support 25,300 pounds. The questions you must ask is, can the ground my racking is on support the weight imposed on it? And what is the safety factor? If you have some racking in your shop, go ahead and take a look and see if you have that information for your storage racks. Example 3 involves powered mobile equipment. Power mobile equipment has made working at heights easier and much safer than the other options available years ago. Telehandlers, skid steers, scissor lifts, and articulating boom lifts all serve very separate purposes and functions. However, where all these pieces of equipment find common ground is in different categories like training, maintenance, and repair. This section of the presentation will focus on Part 11, Section 6, titled Construction, Repair, etc. of Powered Mobile Equipment. The legislation states, an employer, contractor, owner, or supplier shall ensure that each unit of powered mobile equipment is constructed, structurally repaired, inspected, tested, maintained, and operated in accordance with the manufacturer's specifications or an approved standard. This is fairly straightforward. If you are an employer, contractor, owner, or supplier, you shall ensure that each unit of your powered mobile equipment meets these standards. The part that is often throws people for a loop is the term approved standard. What does this mean, and how do you know you are meeting an approved standard? This is what we'll be spending the rest of our time on for this section. Go to the Saskatchewan.ca website and search for the approved standards and practices. This will bring up, as the first search result, approved standards and practices, safety in the workplace, government of Saskatchewan. Click on that link. Any regulation that references an approved standard will be available on this page. Just click the part that the specific regulation is in, and you will be provided with the approved standards for that regulation. For example, so I have opened Part 11, Powered Mobile Equipment. If you look to the image on the screen, you can see the two regulations that reference an approved standard, 11.6 and 11.10. If you remember back a few slides ago, we spoke about 11.6, construction, repair, etc., of powered mobile equipment. The third column to the right outlines the different approved standards for that regulation. By going to the CSA Community Group webpage, I can look up any one of these standard reference numbers to ensure I am meeting the approved standards set by the CSA. Example 4, safeguards. It is without a doubt that safeguards are integral to the health and safety of workers on site. Safeguard prevents hands, arms, and any other part of the worker's body from contacting dangerous moving parts. Without proper safeguards, workers are exposed to dangers that could result in lost time, injuries, or worse. The law regarding safeguards is not much different than the definition. When we read through the first part of the regulations on safeguards, it explains that if a worker can come into contact with any dangerous moving parts of a machine, a pinch point, cutting edge, or point of a machine at which material is cut, shaped, bored, or formed an open flame, steam pipe, or other surface with a temperature that exceeds or may exceed minus 80 degrees Celsius or 80 degrees Celsius or cooled to minus 80 degrees Celsius. This part seems straightforward. If any part of a piece of equipment can hurt an employee, it must be safeguarded. However, the second part of this legislation is where the confusion sets in. For this presentation, we will be focusing on one section of this legislation. That is 10-3(3)A. A machine that is equipped with an effective safety device that stops the machine automatically before any part of a worker's body comes into contact with a hazard mentioned in Clause 1A, B, or. So, what is an example of an effective safety device that stops the machine automatically before any part of a worker's body comes into contact with a hazard? There are several. Let's go through some of them now. The photoelectric presence sensing device uses a system of light source and controls which can interrupt the machine's operating system. If the light field is broken, the machine stops and will not cycle. This device must be used only on machines which can be stopped before the worker can reach the danger area. The design and placement of the guard depends upon the time it takes to stop the mechanism and the speed at which the employee's hand can reach across the distance from the guard to the danger zone. The radio frequency capacitance presence sending device uses a radio beam that is part of the machine control circuit. When the capacitance field is broken, the machine will stop or will not activate. Like the device we just talked about, this device shall only be used on machines which can be stopped before the worker can reach the danger area. The electromechanical sensing device has a probe or contact bar which descends to a predetermined distance when the operator initiates the machine cycle. If there is an obstruction preventing it from descending its full predetermined distance, the control circuit does not actuate the machine cycle. Pullback devices utilize a series of cables attached to the operator's hands, wrists, and or arms. This type of device is primarily used on machines with stroking action. When the slide ram is up between cycles, the operator is allowed access to the point of operation. When the slide ram begins to cycle by starting its descent, a mechanical linkage automatically assures withdrawal of the hands from the point of operation. The restraint device utilizes cables or straps that are attached to the operator's hands and a fixed point. The cables or straps must be adjusted to let the operator's hands travel within a predetermined safe area. There is no extending or retracting action involved. Consequently, hand feeding tools are often necessary if the operation involves placing material into the danger zone. Safety trip controls provide a quick means for deactivating the machine in an emergency situation. A pressure-sensitive body bar, when depressed, will deactivate the machine. If the operator or anyone trips, loses balance, or is drawn toward the machine, applying pressure to the bar will stop the operation. The positioning of the bar, therefore, is critical. It must stop the machine before a part of the employee's body reaches the danger area. The two-hand control requires constant concurrent pressure by the operator to activate the machine. This kind of control requires a part revolution clutch brake and a brake monitor if used on a power press. With this type of device, the operator's hands are required to be at a safe location on control buttons and at a safe distance from the danger area while the machine completes its closing cycle. The gate is a movable barrier that protects the operator at the point of operation before the machine cycle can get started. Gates are, in many instances, designed to be operated with each machine cycle. To be effective, the gate must be interlocked so that the machine will not begin a cycle unless the gate guard is in place. Now, these are only a few sections of legislation our members have asked us to explain a bit further. If you have some other examples of legislation you'd like to explain further, or just get more understanding of all the things that are in the legislation, please feel free to contact us. The information is right on the screen and you can find it on our webpage at any time.